Welcome friends. In this video we are going to see Fourier's law of heat conduction and its related problems. What is Fourier's law of heat conduction? It states that in a material in which temperature difference exists, the heat flux due to conduction in any direction is proportional to gradient of temperature in that direction. So heat flux is proportional to dt by dx. Heat flux. What is the unit of heat flux? Watt per meter square. When we remove proportional symbol by equal symbol, a property will come, that which is nothing but thermal conductivity. Unit of thermal conductivity is watt per meter Kelvin. What is thermal conductivity? Thermal conductivity for a material is defined as ability of a material to conduct heat. Silver has higher thermal conductivity than copper. Copper has higher thermal conductivity than aluminum. This is nothing but temperature gradient. Unit of the temperature gradient is Kelvin per meter. If you see this diagram clearly, it shows that heat is flowing in the direction of decreasing temperature, and also heat flux is positive in the direction of increasing length. So this is our sign convention. This formula can be used to calculate total heat flowing in the slab. Temperature at any location can be found using this equation. This is a problem taken from Fundamentals of Heat and Mass Transfer by Enrico Fermi. Consider a plane wall 100 mm thick and of thermal conductivity 100 watt per meter Kelvin. Steady state conditions are known to exist with temperature 1 400 Kelvin, temperature 2 600 Kelvin. Determine the heat flux and temperature gradient for the coordinate system shown. We have to calculate those two values for three cases. First we find for those two values for this case. By seeing just this diagram, we can say that heat is flowing in the direction of opposite to x and slope is positive. So heat temperature gradient is temperature at x is equal to L minus temperature at x is equal to 0 divided by thickness. If you put 600 minus 400 divided by 100 mm, you will get 2000 Kelvin per meter. Substituting this value in this equation, you will come up with the answer 210 to the power 3 watt per meter square, but here the sign is negative. What it means that we already told that heat flows in the direction of increasing length is positive, but here the negative sign represents heat flows opposite to the x, increasing length. So heat flows in this direction. Now we see the second problem. Find temperature gradient at t at x is equal to L is 400, 0 is 600. So you will come up with minus 2000 Kelvin per meter. Substituting this value in this equation, you will come up with this answer 210 to the power 3 watt per meter square. Here the sign is positive. Again I am saying that heat flows in the direction of increasing length is positive, so it is positive, so heat flows in this direction. You can see just by seeing this diagram, because there exists temperature gradient in this direction. Temperature decreases in this direction, so heat flows in this direction. For third case, calculate temperature gradient. T at x is equal to L is 600, at x is equal to 0 is 400. So by putting all those values, you will come up with temperature gradient as 2000 Kelvin per meter. Substituting this value in this equation, you will get minus 210 to the power 3 watt per meter square. The sign is negative, which means that heat flows in the direction opposite to the increasing length. So we have to be very careful in sign convention. Thank you friends.